today's video, we will take a look at using one-variable equations to solve some word problems. Remember, the word equation means that it'll have an equal sign in our mathematical statement, and so no matter what we do, we'll need to keep things balanced or equivalent on both sides of the equation. The local steakhouse has a Monday night BOGO special. Buy one steak meal, get the second one half price. If Mike's total bill comes to $48, how much does the regular priced meal cost? Now, we can solve this using a one-variable equation. We need to first figure out the unknown. The piece of information we don't have is how much a regular meal costs. So, if we're going to solve this algebraically, we need a variable to represent our unknown. In this case, let's use the letter m. Now, oftentimes people choose to use the letter x as their variable, but in this case, we're going to use the letter m to represent meal. And also, to be honest, we're not using the letter x in this instance as it is hard to discern from the multiplication sign on this interface. Now that we've established m as our unknown, we need to go with the information we do have. We know that the bill is $48 total. That means that the cost of one full-priced meal plus the cost of a meal at 50% off, or 50% of a meal, add up to a sum of $48. We can write this as m plus 0.5 times m, which is 50% of m, equaling $48. When writing algebraically, you can actually remove the multiplication sign that is found between the number 0.5 and the variable m and put them side by side, and it is understood that those two values are multiplied. So now we have the cost of one m, or a meal, plus half a meal equal to $48. We can add these two variables together to get 1.5 m, or 1.5 meals, equal to $48. Now that we know 1.5 meals costs $48, we need to figure out how much one meal would cost, or just an m. In other words, we need to isolate the variable m. To do that, we need to use the opposite operation that is in the current value. So 1.5 times m, the opposite operation would be divided by 1.5. So if we divide 1.5m by 1.5, we need to do a division on the other side of the equation to keep it balanced. So that means we would also need to do 48 divided by 1.5. 1.5 divided by 1.5 leaves us with 1m on the left-hand side of our equal sign, and $48 divided by 1.5 leaves us with $32. That means that the cost of a regular meal is $32. Let's check our answer, just to be sure. So if one meal costs $32, then half of 32 is $16, so $32 plus $16 gives us a total bill of $48. That makes sense, given the information we had in the original question. Fun Uncle Ron gave Maya $2,000 for her birthday on the condition that she invests the money. She puts some of it into her savings account at 5% and invests some of it in a GIC at 7% simple interest. If she gets $130 in interest from the two invested, calculate how much she invested at each rate. This word problem can also be solved using a one-variable equation. Now, it does ask how much she invested at each rate. And in the end, our final answer will actually include two values. However, there is actually truly only one unknown piece of information. Let's see how that works. So it seems like there are two unknowns, how much she invested at 5% and how much she invested at 7%. Let's start with the 5% and use the variable m for money to represent how much she invested. Now, here's the key. She can only invest whatever is left of that $2,000 in this second GIC. So she's got $2,000, subtract whatever she invested in the first one, And that is how much money she can invest in the second. Okay, so now we know the amount she invested at 5% will be represented by M, and how much she invested at 7% will be represented by 2,000 minus M. So M times 5%, or M times 0.05, can also be represented as 0.05 M. This will tell us how much money or interest she earned on that first investment. $2,000 minus M multiplied by 7%, or 2,000 minus M multiplied by 0.07, or written as 0.07 bracket 2,000 minus M. All of these forms are equivalent. However, that last form, 0.07, which is our constant or known number, multiplied by our variable, which in this case does have numbers in it, and that's okay, 2,000 minus M, is the most proper notation. Now that we've got notation covered, let's get to creating our equation. So, the amount she invested at 5%, 0.05 M, plus the amount she invested at 7%, 0.07, multiplied by 2,000 minus M, is all equal to the $130 that she earned. Now, we need to look at this equation and consider the order of operations, or BEDMAS. The first thing we need to do is brackets. There's nothing for us to currently solve in the brackets since we don't know what M is. No exponents. Now we look at multiplication and division. So there is a multiplication where the number is touching the bracket. So we need to look at 0.07 times 2,000, which would give us 140. We also need to multiply 0.07 by that M that's in the bracket. So our new statement is 0.05 M, nothing's changed there, plus 140 minus 0.07 M is equal to 130. Our next step is to collect like terms or bring all the variables or M's together. So we've got 0.05 M and we've got a negative 0.07 M. Don't forget that we need to consider that as a negative. So if we're bringing them together or collecting them together, that's 0.05 M plus a negative 0.07 M, which gives us negative 0.02 M. Then we've still got our 140, and that is all equal to 130. The value hasn't changed. We've just collected the terms to be together. Let's start working on isolating that variable. First, we'll deal with the constant 140. So negative 0.02 M plus 140, its opposite operation is subtracting 140, is equal to 130 subtract 140. If we do it on one side, we've got to do it on the other. That gives us negative 0.02 M, which is equal to negative 10. Now, negative 0.02 M divided by negative 0.02, the opposite operation to multiplication, is equal to negative 10 divided by negative 0.02. Dividing to isolate that variable means we're left with M is equal to 500. So now we know what M is, $500. That means she invested $500 at 5%. We've just got to figure out how much she invested at 7. So $2,000 minus M, or $2,000 minus $500, is equal to $1,500. So let's check our answer just to be sure. 5% of $500 and 7% of $1,500 is 0.05 multiplied by 500 plus 0.07 multiplied by 1,500. That's $25 plus $105, which gives us a sum of $130. Again, this makes sense with our original problem. Therefore, Maya invested $500 of her birthday money at 5% and $1,500 of it at 7%.